mentioned, my name is Aaron Szynski. I'm the product manager for the Cartapack, but I'll introduce myself in more detail in just a few minutes. I'm here to talk with you this morning about spatial intelligence and how we can integrate GPS and field data technology for smarter decision making in your business processes. But before we do, I'm really going to kick us off with a poll. This is my first time using Demio, so if this doesn't go well, that's all. Just a real quick poll for you, and then we'll jump right into it. The poll is really centered around how effectively are your organizations using high accuracy data GNSS technologies in your business processes today, both by you or other teams within your organization. And we'll give about a minute or two, and or not even that, probably 30 seconds before we take a quick look at these results and move on. This is actually shaping up pretty close to the way I expected. And the reason I sort of chose this question is no matter how the group answers, it means we're in the right place. We're well on our way to this journey of using this GNSS technology. We're not even started yet, or we're just kind of beginning on the adventure. But either way, we're in the right place to have the conversation we're here to have today. But I'm really encouraged to see 55% of the users indicated that both GIS and your cathodic protection operators are using this data effectively today. That's pretty encouraging. So with that, I want to go over our agenda really quick before I jump into it. We just went through our poll, so thank you for participating in that. We'll go over who I am and why am I here today. We'll talk a little bit about GNSS versus GPS, and we'll try to do a little 101, cut the jargon. Talk about GNSS devices, GIS, and correction services. And then lastly, focus a little bit on what's new in the world of high accuracy GPS, GNSS technologies. So first, who am I? I'm Aaron Szynski. I'm the product manager for Cartopack. I've been with the Cartopack team since 2018 and with American Innovation since 2019 when they acquired Cartopack. In my past life, I served 8 years in the United States Air Force doing satellite communications and overseeing nuclear security systems. So I feel like satellites have just sort of been around what I have done for as long as I can remember. Prior to that, role as product manager here at I also worked on the implementation team. So I have about 8 years experience with Cartopack around the application and deploying it to our users. So I have a really good understanding of our application, our software suite, and the customers and how we help solve their problems. So I'm really here to talk to you today about the changes we see in the GNSS world and what does it mean for us here at American Innovations and you as the user of these products. So AI, PCS, field data collector users are becoming more acquainted with high accuracy GPS workflows through just the nature of the technology and the business evolution. And we'd like to use this opportunity to share some of the exciting changes in the industry and how we can improve your workflows utilizing these new technologies. So first, a little bit of basics. Cut the jargon when it comes to GNSS and GPS technology. We're all familiar with the term GPS. It's something we've all been using before our phones could navigate us around. We had TomToms and Garmin's that would navigate us around the streets. And at that point in time, we all called them GPS devices because that was correct. They used one constellation. They used the Global Positioning Systems series of satellites, which is a US based constellation of satellites that provides basic navigation technology. However, today the technology has shifted quite a bit, and GNSS stands for Global Navigation Satellite Systems. And you can think of that as GPS with more GPS. Essentially, is what that means is other entities, other countries, or bodies have their own satellite systems to perform global navigation, and we want to include those in our technology. And those include Galileo, which is a European constellation, Beidou, a Chinese constellation, and GLONASS, a Russian constellation. These can all be used in conjunction with the US-based GPS system to call what we just refer to as GNSS, a much broader term than GPS, as it includes all constellations around the globe. There are additional ways we can increase the accuracy beyond just satellites. So I'll talk about that in just a little bit as well. But this is a little bit of what's the difference between GPS and GNSS? Because I hear the terms used interchangeably often, and you may even catch me doing that in our presentation because it's the way we've all learned to speak over the last 20 years. But whether you're locating a test station, recording a distribution tie-in, GNSS helps you collect faster, reduce rework, and it increases the confidence in the work that you did out in the field. So a little bit, why GNSS and why now? Why are we talking about this after all the years that cathodic protection and your operators have been out collecting this data, doing their surveys? Why are we so concerned with GNSS technology all of a sudden? As I mentioned, the PCS field data collection users are becoming far more acquainted with high accuracy technologies. And as this trend continues, we're also seeing that your organizations are becoming more tightly coupled with the GIS teams within your organization, those who take high accuracy collected data and maps, and they align them to tell really, really unique stories, make better process driven decisions, data driven decisions, and make sure that they're using the information in the smartest way that they can. And GPS technology really has really helped move that forward. So we're enabling CP, that's both cathodic protection and Cartopac teams, to collect high accuracy GIS ready data on the exact same hardware using the same tools that we have, that you already have available to you. So with a much broader audience being enabled on with GNSS technology, I just want to talk to you about why and how can we improve this accuracy, and what does that mean for your GIS teams. First, a little bit, GIS teams expect high accuracy data. Why? The highest and easiest answer to look at is they want regulatory confidence. We all have different regulations that we each try to abide by within our respective duties, and GIS is no different to that. GIS is bound by regulations regarding data accuracy, PHMSA requirements, DOT requirements, and regulations in reporting. So as a result, they want data that's going to come in accurate, that they can trust. Having to ask your field users to go back out to a data site, or uh, forbid have to dig up a backfilled piece of pipe, that costs time, that costs money, and it costs effectiveness. So the hope here is that with high accuracy GPS technology, we can get the data, we can get it right the first time, and it supports meaningful audit trails and important survey history regarding your assets out in the field. Additionally, it provides better spatial insight and reliability, dependable high accuracy collections in GPS hostile environments, which is sort of a silly term, but at the end of the day, it really does mean GPS technology is limited by your environments. It's limited by trees and buildings, solar flares, and even adverse threats from other nations, for example. So GPS is not a perfect technology by any stretch of the imagination, but with the tools we have today, we have a very dependable high accuracy solution available to us at all times. Additionally, GIS really expects a clean integration. This is a clean integration into the existing data models that feed these data driven decision processes, such as pods, a pipeline, or the pipeline open source data model, or UPDM, which is put out by Esri, eventually leading into the Esri utility network, which many of you are, if you haven't started dealing with, you more than likely will soon, as it's becoming the future for many GIS teams. At the end of the day, though, our real goal here, and the goal of the GIS team, and they can do this better with high accuracy data, is to make spatial data your ultimate foreign key. I said this a lot. It's one of my favorite little catchphrases. It probably resonates best with the GIS and the database teams in the crowd, but allowing location, allowing spatial data to be what relates your asset to nearby assets in a digital world is incredibly powerful. And making spatial data the ultimate foreign key starts with high quality, highly accurate data. I would like to take a quick second to talk about some of the GNSS receivers that we support here at American Innovations. This is not an exhaustive list by any stretch of the imagination, but I want to talk about some of the ones we see the most frequently. It's worth mentioning that these modern receivers, they use all four of the constellations we mentioned earlier to improve accuracy and perform reliably in these tough, hostile environments, improving accuracy, reducing acquisition time, and increasing reliability. Common GNSS receivers we see here within American Innovations include the Juniper systems, which many of the PCS FDC users are familiar with. This could be the GNSS GNS3S, H, or M, really, as they have a very similar form factor for all of them. Additionally, we see a lot of the EOS positioning system receivers as well. That includes the Aero Gold and the Aero Scotty on the far right hand side, which is a next generation system that we're seeing a lot of traction with. And lastly, I don't want to forget the DVM. It may not be purely a GNSS receiver, and we may not use it in that regards, but many who work on the FDC teams know that there's a GPS device in here and it's used for timing, but we can also get spatial data from it if you don't have a more accurate solution available. So I didn't want to leave our favorite DVM off the list today, but it's also part of the solution that helps us get these high accuracy points that we rely on. So these are the tools we can use to go through and get our highly accurate data. And out of the box, all of these are incredible receivers. You can get yourselves down to a foot of accuracy just walking around with the majority of the receivers you see up here. But sometimes that's not quite the accuracy that your GIS teams are looking for. So I want to talk a little bit about how can we further improve that accuracy? How can we take it to the next step? And we're going to talk a little bit about correction services. There are various ways you can take the signals received from a GPS and you can perform some level of mathematical calculation against it to even better derive your accuracy location. And I'm going to talk about a couple of these. First is what we call real-time kinematics, or RTK. It's really the process of using an active internet connection to reach out to other GNSS receivers out in the world that are broadcasting their location and using that information to triangulate your specific location with a high degree of accuracy. And that's down to the decimeter level. So it's highly accurate and it's highly reliable. It's very fast and it's very effective. You have very low downtime. You're able to begin collecting data immediately. The downsides of this approach is it requires an active internet connection at all times. Many of you on the FDC team know that you don't have an active internet connection all the time. That's why we have offline workflows. And some of these may also require some subscription service. May not always be true. Many Department of Transportations provides statewide RTK networks, but that's not always the case. And you may have to pay for a subscription service for that. So this is, I would say, 1A RTK is the top of the line in terms of what we see for highly accurate collection out in the field. It's utilizing RTK technology with active internet connections. But there are other options as well. First, let's talk about post-processing. It allows you to collect highly accurate data as well, but it often requires a after hours and a back office process to help correct your data to the highly accurate location that we're hoping for, that GIS expects. So let's talk a little bit about this. This is done through really the same principles, the idea that you have your own base station data and there's another rover data out there and you can share information about each other and you can use that information to triangulate and correct your location. However, you don't have internet. So is how this process works is we save all this information in the background, and this other rover over here, it also saves all of its information in the background. At the end of the night, we share information with one another and we correct that location for you. It does not require any active internet at the time of collection, and the accuracy is comparable to RTK. So it's a really good low cost alternative to real-time kinematics. However, it does provide limited field confirmation of accuracy. You don't know how good the data you're collecting is until it's been post-processed because you don't know the quality of the data of surrounding base stations. So there's just a little bit of inherent risk with post-processing. Additionally, it has longer acquisition time and typically slightly longer time to collect your data. That's because you require more information from the nearby satellites and you log more of that information to perform these calculations down the line. So it's a little bit slower and it doesn't give you that confidence, that warm and fuzzy feeling inside that it's doing what it's supposed to do properly. As a bit of a jest, you notice I used the same image for both of these. And the idea here is to show that it is the same type of technology. It's the same process and principle, but we're applying it at different times. And that's sort of what gives you that illusion of one is real time accurate with real time feedback, opposed to something that happens in the back office. Again, just a quick summary of the two. These are the most frequent ways that we see high accuracy corrections out in the field today. But there is another technology emerging that I really want to talk with you about today, and that's the primary reason I've come here. So enter Galileo high accuracy. So for those who paid attention a few slides ago, you recall Galileo is the European GNSS constellation. Though it is a constellation that is owned and maintained by the European Union, it does surround the entire globe, just like all three of the other constellation systems. So Galileo high accuracy, or GHAS as they're calling it, is in addition to the technology we have today. It's done by operating on additional frequency band that has better prevention against multipathing and frequency interference, that is giving us the ability to get additional corrections out in the field down to the 25 centimeters, which is just shy of 1 foot of accuracy, close to 8 inches of accuracy, out in the field with no additional correction services required. That means no post processing. That means no real time corrections. With purely what we'll call autonomous data, you're able to get sub-foot accuracy out in the field using these new next gen GNSS devices, which is incredibly exciting technology.
Karen,
Global. Oh yeah, sorry.
we got a couple of comments. Well, one comment from William and then a question from Casey.
So many
So,
words in the chat, please.
Yeah, William was asked, well, just making a comment about that some countries here in Latin America with some rough terrain conditions, they use RTK, GNSS base stations and transmitters to verify pipeline deviations due to changing climate conditions, slides, and earth movements to establish HCA, which that's pretty interesting.
That really
Um,
is. It's a perfect example of how these use cases and how this technology overcomes challenges that you otherwise wouldn't think if you're not involved in the GNSS world. Thank you for that,
yeah.
William.
Yeah, and then Casey had another question here. So, are we limited by the FDC application on which GPS GNSS equipment we can connect to our device to connect the data?
Absolutely not. That's a great question. All the receivers we showed up here today, barring the DVM, are generic GNSS receivers that can be connected to really any mobile device, Windows, Android, or iOS via Bluetooth. And there are a wide array of applications you can use to collect this data, whether it be real-time corrected, post-processed, or even in the future with this Galileo high accuracy. So you're not bound to the FTC application, you're not bound to the Cartopack application. The technology is pretty universal. I hope that answers your question. If not, please feel free to follow up and we'll make sure we continue talking through that. Thank you, Christiane. Um, as I'll show in just a moment, Galileo high accuracy is currently slated to have about 2/3 global coverage, which is a really powerful swath of the Earth. It's cost effective in the sense that it costs you nothing, assuming you have a high accuracy receiver capable of receiving this new L5 frequency band that Galileo high accuracy leverages. It has multi-constellation support, and more specifically, it has very good multipath frequency defenses. And that's just the idea that as your satellites push out all these GPS signals, they're going to bounce off everything they come in contact with, including the atmosphere and the ionosphere. And multipath reducing technologies enable it to get through those barriers more effectively without refracting their signals and losing quality along the way. So not only are we operating on new bands, we're also allowing you to have better absorption through some of those refractive signals, if you will. So really powerful stuff we're seeing, and I hope to see all the other constellations follow suit here in the next decade. That's an excellent point, Lon. Thank you for that. The geode is currently supported in FDC. And the geode, for in case I didn't highlight that well enough, let's go back here really fast. There we go. The geode is the Juniper device on the far left hand side. Thank you for that, Lon. A quick data map to show sort of what we are seeing with Galileo high accuracy as it continues to roll out. This is the global coverage map we talked about. Roughly 2/3 of the globe is covered. We do lose Australia, New Zealand, and some of the areas directly north of that. It also excludes a little bit of Alaska and the uh, top corner of looks like uh, Vancouver, perhaps. But we do get all of Central America, the majority of Northern America, Africa, and vast majority of Europe as well. Right now, Global High Accuracy is deploying worldwide. It's currently live, but right now it takes about 5 to 10 minutes to get down to that acquisition, down to that accuracy level you're looking for, where they expect by the time all the satellites are deployed within the next year and a half, it could take less than 5 minutes to get that frequency. So it's, or excuse me, to get that acquisition and that correction signal. So really encouraging. They are about a year and change out from being fully deployed with Galileo high accuracy. I'll say near worldwide, as there's currently no plans to move into the currently blocked out areas that I'm aware of. And that's really what I wanted to kind of talk about with Galileo high accuracy. I see some other comments coming in, and I would like to address those in just a second. So with that, I'm going to move into one last slide before we open it up for questions and hopefully an open discussion. So, what does this mean for you? Here's where I would like to sort of challenge you to determine how you and your organization could benefit from higher accuracy GNSS workflows. Understand who those people are, and are we using that technology today? Is the spatial data you collect that you're doing as part of your daily job today being used in the decision making process yet? Should it be? I contend it should. And lastly, do you even know who in your organization would be interested in high quality GNSS data? Are you talking with those teams yet? Because if you're not yet, there's a good chance you will be as IT becomes a bigger decision maker and GIS becomes a bigger decision maker, and the processes we participate in, the tools we use, and the technology that we leverage to do it. So with that said, I would like to sort of thank you for taking some time to sit with me today, talk about high accuracy GPS. If you have questions, we can open it up. And otherwise, we have about 4 minutes left. And I talked about a couple different options that I'm just excited to talk GNSS technology with if anyone's interested. And that includes RTK enabled line locators, GNSS technology with tilt compensation, or even hands-free GNSS mounting options. So with that said, I am open to talk GPS with anyone who is interested. So thank you very much for joining today. I really appreciate your time.